In this video, we will be discussing about resistors in series. If you can observe this particular circuit diagram, you can see an ammeter, and this ammeter always records a constant value in a series combination of resistors, because in a series combination, we know that the current flowing throughout the circuit is constant. If you can see the wire connections, all the resistors R1, R2 and R3 are connected end to end in series. So, in series combination, current flowing through each resistors are the same. Now, if you can observe this particular circuit diagram, which consists of a series of resistors, so combined in series combination. So, between the points X and Y, you can see three resistors R1, R2 and R3, which are connected end to end respectively. So the potential difference across the complete circuit is capital V. So the total potential difference is capital V. And the potential difference across R1 is V1, R2 is V2 and R3 is V3. Now that the total potential difference across a combination of resistors in a series is equal to the sum of potential differences across the individual resistors. So basically the total potential difference is equal to the sum of individual potential differences. That means this potential difference, the total potential difference capital V is equal to the sum of all these potential differences of individual resistors. That means capital V is equal to V1 plus V2 plus V3. So if you add all these three, you will get the total potential difference present in this particular electric circuit. So V is equal to V1 plus V2 plus V3. So V is equal to IR. We know Ohm's law. So let us apply Ohm's law here. So V1 is equal to IR1, V2 is equal to IR2 and V3 is equal to IR3. If you can see, the potential difference and the resistors are changing, but the current is not. Why? Because current is constant. It is same in every resistor in a series combination. So like similarly how you combined V is equal to V1 plus V2 plus V3, let us also write V as, so V can be written as IR. So let us write V is equal to IR. V1 will have IR1, V2 will have IR2 and V3 will have IR3. So just write it in the form like V is equal to IR. So if you apply it in the equation and write it, you will get IR is equal to IR1 plus IR2 plus IR3. Or you can also write R series. That why are you writing it as RS? S means series. So since it is a series combination, we can also write it as R capital R S is equal to R1 plus R2 plus R3. So the total resistance is equal to R1 plus R2 and R3. That is the sum of the individual resistances in a series combination. We can conclude that when we see several resistors joined in series, then the resistance of a combination RS is equal to the sum of their individual resistances R1, R2 and R3, and is thus greater than any individual resistance. So in usually a series resistance, you can see that the total resistance of a circuit is equal to the sum of the individual resistances. So in this particular circuit, it is the sum of R1, R2 and R3. And you can see RS or the total resistance is always greater than all the individual resistances because it is the combination of all. So this is how you can actually calculate the complete resistance in a particular combination of series circuit. So for example, if there is a circuit which has series combination of resistors, you can actually calculate the total resistance with the formula or by taking this particular format as RS is equal to R1 plus R2 plus R3. That is, the total resistance is equal to the sum of all individual resistances. Thank you.